share my little plasma cutter. Having a lot of fun building it. I think it's coming out pretty good. Hooked up my 24 volt power supply. I gotta be careful with that. I don't have it hooked up very well, but I was just doing some motion tests. Seems like it's going to work good. Here's the Z adjustment. You just loosen the leg up, and then you turn the little handle, and it lifts up or drops it down. That way, I'll be able to set the height of the torch, and all four corners are independent. So even if the piece is just a little unlevel, or I don't know, crooked, maybe the ground's not good, I'll be able to adjust the height. I think it'll work nice. I've been doing some motion tests, and I'll show you some moving around. It's kind of neat. See, there's the X, moving real good. It's pretty darn strong. The belts aren't tight. I'm just seeing if the design will work, basically. And I'll show you. Let's see here. It's got, the belts are loose, but it's actually good because it'll skip the belt instead of skipping a bunch of steps. I think just like safer, especially for flying around. But I think if the belt were tight, if the belt's tight, I gotta turn that power up. Let's see if I can do that. Turn the power up. Oh yeah, that's a lot better. Pretend the belt's tight. I think it's got quite a bit of power. So yeah, it's nice. Oh, whoops. That one's gonna crash. See, that's why I leave the belts loose. Sweet. I can run Gerbil on it, and I'll get a file to test it out. I've had the torch hanging on it, and I was running it on 12 volts, and it worked great. I mean, it's got plenty of power and torque to move the torch around. As a matter of fact, here's the torch. It's really light, but it's got plenty of power to move it around. Torque amount, something like that. I just gotta probably drill it. When I get it all figured out how high I have to make it, I'll just drill it, and probably super glue works really good with the plastic. But I just wanted to show that, yeah, it moves. It's kind of neat. Gerbil's kind of fun to play with. I've never played with that too much before. Yeah, see? It's cool. It's coming along. It's coming along. I'll give you a better look at some of this stuff. See, here's how the belts work. I wonder if I can turn on the light. There we go. Now the motor turns that sprocket, and it just runs on these bearings, and then the whole carriage rides on these bearings. And what stops it from having any side play is this little washer. Kind of just stops it from moving. And you'll see here, I'll move this other end and show you how it works. And the other side's basically the same. Got the little pulley. So once the belts are tight, and if the pulley's not skipping, then it should run real smooth, and that should keep it like square to the frame. It relies more on the belts than like the rollers and stuff, but it does stay pretty nice. Here's the carriage. I just have it kind of wired on there right now, but it moves really easy. Plenty of power with those Nina 17s. And here's the end. You can see the belt just has this spacer. I designed it to have the belt come clear down here, but it changes the tension when the carriage gets close. I didn't know it would do that, but anyway, oops, this is loose. What I need to do is cut some more of this 3/4 inch tube and stick it in here instead of this smooth rod, and just have some of this threaded rod welded on the end, or weld a bolt on the end, something that'll make it pretty nice. But anyway, there's my captive nut. Worked really good. I got captive nuts all over this thing. I put them on here and on the little feet. But you tighten this and it locks the threaded rod so it can't really spin, and it's a lot more stiff, I guess you would say. But yeah, it's coming along cool. Not long. Not long I'll be able to try it out for good. Talk to you later.